All right, today we are going to do something called representing variables. And just reading the instructions here, my instructions say I have to simplify, which basically means taking this long expression that I have here and making it shorter. And I'm doing that by combining the like terms together. And what I mean when I say like terms, I have a 5 here and a 1. They are both constants. They are alike. I can combine them. I have an x squared and a negative 2x squared. They are also like. I also have a negative 2x and a 5x. That's positive. They're also like. So it's the same type of terms that we could actually combine them. And if you still don't understand that, you will by the end of this little module. And then finally, we are also, once we get this shorter by simplifying it, we are going to evaluate our expression if x equals 3. We're going to do all this in two different ways. The traditional algebraic way. But again, I want you guys to be able to visually see what's happening, not just know the rules. So first we are actually going to do all this using Algebra Tiles. And the first thing I'm going to do is represent each of these terms. They are all called terms. And I'm going to do that with the tiles. So the first thing I'm going to do is I always like to represent first the very large pieces, which is x squared. So all the x squared terms. And it's okay if you regroup them. You don't have to represent 5, then negative 2x. You can just simply regroup them, and that's what I'll do. So I have to represent negative 2x squared. So blue in this case being negative, I am going to pull 2 x squared blocks. That's what these things represent, my x squares, and they're blue so that they are negative. And then I have to pull 1 positive to represent my 1 positive squared. And there are no other x squared terms. So then I'm going to move to my x terms. I have a negative 2x, so I use these, a lot of people like to call them rods, sure. So I'll use these rods or sticks, but these do not represent, by the way, tens. They, sorry about that, these do not represent tens like in your base 10 blocks. They represent an x variable. So now I got negative 2 here. I got 2 of the negative 2 x blocks. And I need, let's see here, 5 positive x rods. Oops, so I will bring over 5 positives. There's 2, 3, 4, and I don't know what happened to that guy, but there's 5 right there. And then finally my little constants, which are represented by little tiny little chips. So I have 5 positives. 1, 2, 3, 4, 5. And then I have 1 additional positive, so no negatives. And there you go, there's 6. So now not only have I represented my full expression, I've regrouped them. And it makes it easier to do the next step, which is simplifying. Simplifying means, again, making this expression shorter by combining the like terms. When you work with the algebra tiles, combining like terms essentially means 0 pairs. So I'm going to draw my 0 pairs. So I have a 0 pair here. And if you don't understand what 0 pairs are, take a look at the videos looking at integers. So there's 1 0 pair. Here are 2 0 pairs that all equal 0, and I could take these out, draw an arrow here to represent that they are being eliminated. There are no 0 pairs with my constants because they're all positive. Now I have simplified. So I actually have now this block here left, these 3 left, and these 6. And if I were to write this out, this would be negative x squared plus, because these are positive, 3x plus, because all these are positive, 6. That expression here is all this simplified. And I'll go over that now using straight traditional algebra. So I am going to combine all of my like terms. So just like over here, I have negative 2x squared, and I can combine that with a like term to x squared, which is right here. I have 2x squared terms. I have a negative 2 and a positive 1. So if I put negative 2 together plus 1, I get negative 1. And that is an x squared term. Now you don't have to show the 1 because you already have x, but I'll show the 1 here. Now I have negative 2x and 5x. So that's my next set of terms. 5 and a negative 2 would give me positive 3 if I put those together. So positive 3 being plus 3x. So that takes care, by the way, of that term, that term, that term, and that term. Now all I have left is 5 and a plus 1. Don't forget, though, that negative belongs to this negative 2x here, so ignore that. So I have a positive 5 and a positive 1. You put those together and you get positive 6. And as you can see, it's the same thing. So there's my new expression. I have simplified by combining 0 pairs, or by taking out 0 pairs, and here in algebra by combining the like terms. Now one last step, I'm just going to erase this line here. My next step is to now evaluate if x equals 3. And now all that means is I am going to now replace my x variables with the number 3. So the question is just suggesting that now we know what this unknown is, and it's 3. So I'm just going to do that. So I have negative 1. That x, put in brackets, means 3, just like what the instructions say here. And that is squared. And I have to add 3. This x is 3 again, and then add 6. So first thing, and that's why I have BEDMAS written down here, is solve the brackets. There are no true, these are brackets, but there's no operation inside. So now e, which is exponents, I have to solve for this exponent first. 3 to the power of 2 is the same thing as saying 3 times 3, which is 9. So I have negative 1 times 9 plus 3 times 3 plus 6. I'm going to do the two multiplication parts together. Negative 1 times positive 9 equals negative 9. Positive times a negative equals negative. And then 3 times 3 is 9, so that's plus 9 plus 6. Negative 9 plus 9, well, that's easy. That's 0, and I'm left with 6. And there's my final answer. So we have just represented this expression here with all of these blocks. Then we simplified it by taking out 0 pairs and by combining the like terms here in algebra. And then we evaluated if x equals 3. So 3 or 4 different things in algebra all in one shot. There you go. Bye.